Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to working on the Tally-Ho Capstan project, and we are working on the adapter plate that goes on here. We've started using my Kearney Trekker 2D rotary head milling machine over here to do some radius milling on some arcs, and we're going to be continuing to do some of that as well as some other milling on this part to get it finished up. So we're going to kind of pick up where we left off in the last video, and I get in here and try to get this part finished up today. All right, so for our next cut, what we need to do is we need to cut down, what is that, 0.512, cutting a step out in here, and we need to go to a radius of 2.959. Yep, okay, so what I'm going to do, I think, is I'm going to start by, I'm going to make these at the full 0.512 depth, but I'm only going to do 200 thousandths off the back each time. So we're going to try 200 thousandths anyway and see how that does. So what I need to do is I need to kind of touch off over here. Well, first thing I want to do is move my arc, my radius out 200 thousandths, and I can do that right here on the dial. Let me loosen up these locks that I had locked in place before. And I can just read right off of this. I'm just going to call that 50 thousandths right there. So we'll go 100 thousandths, 200 thousandths right there. I'll really lock down everything. Now what I'm going to do is we're going to just move our head down until we touch off there. We'll start by just raising up a little bit here, and then I'm going to turn my spindle on and very carefully raise this up until I just see a chip cut off of there. All right, there. We're just barely starting to cut. So I'm going to back that around. I'm going to zero out my Z-axis. And digital readout. And I'm going to dial in 512 thousandths beat. And we go 100, 200, 300, 400, 5, 12, 510, right there. And I think I'm going to take a little bit slower of a cut this time. I'm going to go to 3/8 of an inch, or 3/8 of an RPM, so 3/8 of a rotation per minute, and then go at 8/8 over here on the go. We'll let that swing back around. go back around. And we're going to 959. Just going to go ahead and dial it in all the way. We'll lock our locks again. All right, this should be our final pass here on this step. All right, we got that one done. Now we've got to cut another slot back off the back that basically will go out to the back. So let me get set up for that one and we'll come back and start doing it. All right, so this is where things are going to get kind of interesting. This head on this mill will offset 4 inches. So a 4-inch radius. You make an 8-inch circle. And then you run out of travel to be able to move it out any farther. Here's the problem we got. So our next radius that we need to cut is 6.472 inches. So it's 2 inches beyond the reach of it is just going directly into the spindle. So how are we going to do that? Well, the good news is there is a solution to the problem. It's called the universal head. We can put the universal head on here and actually get 4 more inches of swing on it. Let me show you what this thing looks like. So this is the universal head. Basically, this thing slides up over the spindle. There's a linkage that goes down in here and spins this, and it goes over to the right, and then you've got, or over to the head here, which you can actually rotate to whatever angle you want. Now we're going to leave it just at 90 degrees, straight up and down, or 0 degrees, but it offsets it by 4 inches. So we can add 4 inches to the 4 inches up here and actually be able to get 8 inches of radius out of this machine rather than just the 4. So what we're going to do is I'm not going to break down the part here. I'm not going to break down things off the center. I'm going to drop the table down. We're going to pull the end mill that's in here out. We're going to mount this head on here. We're going to reinsert another end mill over here into this piece, and we should be ready to go. So let's go get her done. So I've got my universal head mounted on here, and again, this gives me an extra 4 inches on my radius that we can do. So I've got this set up for my next arc, which is going to be at 6.472. And I've already got all that dialed in. We've already got our end mill in, same end mill we're using before, 1/2-inch end mill. And I just need to touch off on this, get my depth. I think what I'm going to do is kind of like before, I'm just going to ease down on my depth, get that first arc cut, and then we'll just kind of expand it out one at a time and just eat it out the material until we get all the way out the back. That's the game plan. Let's get in here and do it. So start up the mill, and I'm going to just raise my table up. We've of course changed all the geometry here where my zeros and stuff were on the height. The X and Y is still in their zeros. We're still working off that same pivot point, so we'll swing that around out of the way, and I'm going to zero out my Z-axis, which is the height, and I'm just going to dial in, what were we doing before, 50 thousandths per pass? Let's see, I'm going to try 100. Just going to raise up the table 100 thousandths. I have slowed my speed of my feed down a little bit, or my feed rate down a little bit. Now we're on 1/4 of an RPM, so 1/4 of a rotation per minute. And the reason is as this radius gets longer and longer, the actual surface feet per minute that we're cutting is going to be faster here than on the smaller radius. So I've slowed that down considerably from where we started at. Let's let that come across, and seems to be taking the 100,000ths with no problem. We'll let that ease on around. All right, I'm going to clear some chips out here, and we'll go back to the backs there, and we'll do another feed. I probably could just fine mill in both directions, but I'm just going to do it in one direction. All right, let's dial in another 100 thou on our Z-axis, so raising the table up another 100,000ths of an inch, 1/10 of an inch. Right there, and around we come again. This rotary action of the milling on this machine is a little bit unique, I guess. Not many machines have. There were several other machines out there in this time frame that could do something very similar to this. This was not something that only K&T had the ability to do, Kearney Trekker, but I think many people kind of consider these 2D mills the kind of the Cadillac, I guess you could say, the one everybody wanted. And as opposed to, modern day machinery, we can basically do an arc like this on a modern CNC machine, but you're doing it by moving the table, moving the X and Y. So you're actually moving the table in two axes, and the reality is that because of the table is staying still and the cutter is actually swinging on a true arc, you're going to get a more accurate arc with this type of a setup than you would on a CNC machine. Probably not enough to make any real difference in most situations, but because that cutter is moving on a true arc rather than the table having to kind of zigzag over, you're just going to get a smoother arc. All right, we're going to continue on. I'm going to 512 thousandths on my depth, and once we get there, we'll start easing our way out. We'll bring you guys back here in a minute. All right, this should be the final pass on the depth. We'll go to raise my table up. We're going to 512 thousandths in 11, right there. Let's let it roll around. There we go. I'm going to clean these chips out. We'll swing around. I'm going to get a depth micrometer, check my depth and everything, just make sure we're matching up. And we'll start eating out the rest of that back side back there. Basically, we just have to take this all the way back out the back now. Let's see where we're at here. All right, looks good. So now we need to just work our way toward the back, and we're just going to go about 200 thousandths per pass, I think, until we get there. So let me loosen up the head here where we can adjust it back, make that radius a little bit larger, and see where we're at on 60 right here. I just want to go around. That's 100 thousandths, 200 thousandths right there. We'll lock our head back down. We basically just made the radius a little bit larger on this. And we're ready for our next pass. We are getting back here close to being finished for this step here. I got a couple more passes I'm going to have to make, but I've just been nibbling about a little bit at a time. Cutting that metal out of there, but we're just about through here. Going back and forth. I'm only been still cutting in one direction. If we cut going back, it'd be climb milling coming out of that, which I try to avoid. Do more conventional milling where the cutter is cutting into the work as you're feeding into it, rather than the other direction where the cutter is trying to climb up on the work as it's cutting it. If you got any backlash in your machine, that can be a problem, which I don't think this machine has a lot of backlash in it, but we just try to avoid that situation. We feed in a little bit more, lock our table back down or lock our head back down. Make another pass. To adjust the radius here, I just got a dial right here. I've been doing about 50 thousandths per pass is what we kind of came down on here. And right there. Getting real close to having that knocked out. Probably going to take 2 more passes to clean it up, I think. Next pass is going to get most of it. Go back around. Taking another 50. Let's see if this will get it. We got it. All right. Starting to take shape. So just taking a look at where we're at, we've got all of our radius milling pretty much done now. The next step we've got is I need to make some straight cuts through here. You can see there's a little slot that gets cut out straight in the middle here. And I'm going to take the universal head off, go back to just working off the regular spindle. And this will be milling just like we would on a normal milling machine. We'll be using the X and Y on the tables and locking the rotary head down. So let's go ahead and get set up for that and continue on. So now we need to cut our slot in here. Just going to go a straight slot in here. It needs to be 3 inches wide. It is offset a little bit to one side because the center of this hole is not quite in the center of everything, but no big deal there. We're going to adjust for that. I've got the dimensions here on what my offsets are, and we basically need to, I've done some calculations to figure out what they are with taking into consideration the diameter of the end mill. And let's see, we need to be 164 thousandths deep. So let's get in here. We're going to touch off. I did come in here and recenter on the bore because I am working off the center of this, at least in this direction here. Of course, we'll be making parallel cuts in the other direction, but I do got everything zeroed out where it needs to be. So let's come in here and touch off and we'll start some milling. Turn our spindle on. Start with some down feed here. Let's use the quill. Come in here and kind of touch off on that. There we go. I'm going to zero out my digital readout. And we're going to raise up a, let's see, we're going what, a total of 164. Let's just do 50 thousandths per pass here. Roughly 50. I'm going to go ahead and take my full depth. So we'll just dial that in. I'm going to go to 100. One thousandths deep. Cut back across that. I'm going to 150 now. Cut back across that. And we're going to 162, so let me go ahead and dial that in. We're close to it already. 162. So this should be our total depth on this. And now what I'm going to do is I'm just going to bring the table, move it away from me. We're going to be milling out in this direction, and I need to go a total of 1 inch 367 thousandths to get my width right. So I'm just going to do, well, we did what, about 50 thousandths per pass a while ago, and that was working pretty good. Not quite as deep here, but just going to nibble it out a little bit at a time. Just using my power feed as much as possible here to keep from having to crank as much. I think I can take a bigger bite in what I'm doing. I'm going to try 100 thousandths. Let's see how it handles that. Yeah, no problem. Like before, I'm only milling in one direction because this is conventional milling. We're turning the cutter into the work. If I were to come back the other way, we'd be climb milling, and it would be trying to climb up on the work. And again, I try to avoid that as much as possible. In some cases you can get away with it, but I ain't gonna worry about it. We're going to continue nibbling this out until we get down to where we need to be. On this pass, I think I'm going to go all the way down to that bottom and go ahead and start milling this area out down here. I don't want to get too big of a piece there to have to mill out. I've already taken a pretty good bite. All right. And this should be the final pass on this one. All right. Now we'll start working on the other side. All right, we're going to dial in our 1.133. 1, 2, 1, 3, 3, right there. All right, here we go. This is last pass. All right, let me go make some measurements, make sure everything checks out good, and go to our next step on this. So this is the casting that the piece that we're milling out over here is going to fit down inside of, and this is where things get real interesting. So we basically, got our straight sides here. We've got the bottom down here in the bottom, but we've got these radiuses in the four corners here. And right now, basically, we just got a straight line coming out of each one of those. We don't have clearances for those radiuses. So like down here in this bottom, you know, this kind of just going straight in there, but they've got these radiuses in there we got to deal with. So didn't have a radius gauge this size, but I went over it and just through trial and error found something that's close. It's a 3/4 inch radius, 1.5 inch diameter is roughly what we need to be. That is actually just a little bit larger, but that's fine. But what we need to do now is go over there and basically mill out a little radius in these corners, particularly on this side. This side up here doesn't need much at all because it would have really kind of gone on up in here farther if it had gone straight in. So anyway, we need to see if we can do that. Fortunately, we got the rotary head mill, so we ought to be able to. I've got the areas I need to kind of mill out here kind of drawn on here. And guys, this is not a precision by any means. I just need clearance is all I need. Actually, I need for a little bit more than that to be gone, not by much, in order for me to do this. Now, I've set my radius on this to 3/4 inch radius on the outside edge of the end mill. Again, we got a 1/2 inch end mill, so it's 1/4 inch to the center. So I've moved it out a 1/2 inch, which will give me a 3/4 inch radius. And we can just rotate the head around, and we should be able to swing that arc we want. So I have not calculated the coordinates where my centers need to be. I could do that. It'd take a lot of math, but I'm just playing this by ear. Like I said, I just need clearance. This is not anything critical, so we're not going to worry about it too much. All right, let's get in here and start nibbling these things out. I'll take that up until it just barely starts cutting. And just kind of go around the corner there with it. All right, I had to stop and kind of regroup there because I got to looking at this radius, and it was very clear to me that that was not a 3/4 inch radius. It was a much smaller radius, and I had to stop and think about what I was doing. And I had the right idea, but I applied my offset in the wrong direction. So because we're cutting on the outside of a circle, so you can think if this would be the center point in here, we're swinging on the outside of it. I need, instead of subtracting 1/2 of my diameter, I need to add 1/2 of my diameter to the radius. So 3/4 inches plus 1/4 inch would be a 1 inch offset. I'd put in a 1/2 inch offset, so I was cutting a much smaller radius. I've changed that. We should have that straightened out now. So now I need to kind of come in here and find where we need to be at to kind of start that arc. And like I said, I'm just kind of getting it close. I just need the clearance. If I get those lines out of there, I should be good. But we're going to get as good as we can. So let's swing the arc right here. I'm just going to start this back up. See, table feed. Let's see. So this should. All right, I'm not quite touching there. All right, we're going to go again. All right, here we go. That appears to be swinging that arc pretty close. Just getting it out of there. Right on that radius. That's probably good enough, but I want to make sure I've got the clearance, so I'm going to just take a little bit more. All right, here we go. All right, I think we got that one done. So let's come over here and do this one. We'll bring it on around that corner. All right, I think we're good. Well, I ain't gonna lie, that was a lot of work making that part. So again, this is what's got to fit over this. And I think we're real close. I've got some fine adjusting I need to do in some places. I got a little gap down here up underneath this bottom piece. So I need to figure out exactly if I need to make some adjustments here, there, wherever, but it's really, really close. I just need to do some fine tuning to it. I might be able just to come in here. I know I'm going to have to probably relieve some of these corners because there's some fillets down here in these bottoms, and those may be what's hitting. So I'm going to probably just get in there with a grinder or something and just relieve some of these corners so that we have some clearance, again, for the fillets down in those bottoms. But we're really, really close to having a good fit here. And I mean, I think it's going to work. We just need to do some fine tuning. All right. Well, here we go. That is one of the most complex pieces I've ever machined. And I think it's going to work. I think it's going to be just fine here, guys. So I did it off camera. There's a bronze bushing that goes in here. This is just basically an alignment that's going to go between this adapter flange and the top plate that's going to fit through here that a shaft will go down through, and this will be the actual shaft that goes all the way through this. So this bushing will just drop down into this casting, or this part rather, not a casting. And then this whole assembly drops down in here. This gets captured in here, so it's stuck in between, and it drops down into that board that we got going down through there. And yeah, just got to seat down. We bolt it up, it'll all draw up just fine. And that's basically what we got. Now there's another flange that's going to bolt onto this and line up with this boss here that will have a shaft that goes down to the motor. So this is just this is basically the mounting plate that the other flange is going to fit onto. And that part is actually going to be made over in the UK. It's going to be sent over to me. I have not got it here yet. When we get that, we'll actually bolt all this together. And again, the motor that's going to drive all this will be suspended, hanging from this boss right here. But I think we got that done. I'm happy with how that has turned out. Incredibly complex part, but we got it nailed. We got it knocked out. Well, the adapter flange, I'm marking off the list. That's one less part we got to do. I've also got the bushing made. Again, I didn't do that on camera. It was fairly simple turning job in bronze. It didn't take hardly any time, and I just didn't really feel like it warranted a video just on making that. You guys seen me turn basic stuff like that before, so hopefully you don't mind that. But this project is moving along. So now we're going to be going and focusing on a couple of the other parts that have got to all come together on this. But this is a big step off of the checked off the list, and I'm really happy to have that behind me now. So guys, with that, that's going to be a wrap. As always, thanks for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are greatly appreciated. Hit that bell icon to get notifications when new videos are posted. Big, huge thank you those who support the site financially through Patreon, PayPal. Links for that down in the description. If you can help out there, that'd be greatly appreciated. It really enables me to take the time to be able to shoot these videos and bring you guys the content that we're doing out here in the shop. Guys, with that, we're going to sign off. We'll catch you on the next video again. Thanks for watching.